Good morning, Algebra 2. A little bit different format here. Apologize, this is getting up a little bit later than I wanted to. Came home last night after our live stream and just really wasn't feeling very well, so I ate my supper and kind of got to bed and got a little bit of extra rest this morning. I'm feeling a lot better now, so I don't think it's the coronavirus. I just wasn't feeling super well, so I do actually feel a ton better today. If someone can actually feel a ton better, that makes no sense whatsoever. Like, how can you feel a ton better? Anyway, all right, I'm going to stop being a moron now. All right, here we go. Let's jump into it. We're going to start off with number 12. So this is, I think this is section, I want to say this is section 3 of that same lesson we've been doing. All right, and I'm going to write our problem here. It's a plus 1 over a divided by or over 5. All right, so this is kind of how you have to look at it. I'm sure you've already noticed this, but here your numerator actually is itself a fraction. All right, so I'm going to rewrite this as, okay, so a plus 1 over a divided by 5 over 1. Okay, and if you remember, when we're dividing fractions, what we're going to end up doing is multiplying. So we're going to change this to multiplication, and we're going to multiply by the reciprocal of the second fraction. So it looks like this. So a plus 1 over a times 1 over 5. Okay, and then that gives us, we'll be able to get to our answer here. That's going to be a plus 1. So a plus 1 times 1 gives us a plus 1. And then a times 5 gives us 5a. Okay, and notice we cannot cancel these a's out because of this addition sign right here. Okay, if this was just a by itself, then we could go ahead and cancel them. But since we're still dealing with some addition here, we can't factor this out anymore. It's already completely factored out, so that's actually, this is our answer, right, y'all? Okay, all right, so that's number 12. All right, let me get out number 14 real quick. Okay, number 14. Number 14. Little more work, but same basic concept, okay? So number 14. All right, so we've got a cubed minus 27 over a squared minus 9. All right, and then this is all being divided by, all over, a squared plus 3a plus 9 over a plus 3. Okay. All right, so we're same thing, but I want you to notice there's some things here. This is an a. This is an a right here, not a 9. There's some things here that can be factored, and whenever there's something that can be factored, you want to go ahead and factor it. Okay, so again, if something can be factored, then go ahead and factor it, right? Okay, so that's going to be, if we factor out that top one, I'm going to give you a second here, or a few seconds. See if you can remember how to factor out the difference of two perfect cubes. The difference of two perfect cubes. See if you can remember how to factor that out. Can you remember? There's kind of a format that you follow. Give you another couple of seconds. The difference of two perfect cubes. What does that look like when it's factored out? Okay. All right, so I'm going to go ahead and just for sake of time here, that factors out. So I'm gonna rewrite all of this right here. I'm just going to rewrite it in this area, factored out. Okay, so we're going to factor out a cubed minus 27. So a cubed minus 27 factors out to a minus 3 quantity times a squared plus 3a plus 9 quantity. And then that's going to be over, now I'm going to factor out a squared minus 9. Okay, that is a plus 3 times a minus 3. Okay. All right, now we're going to multiply on this side by the reciprocal of this right here. Okay, so that's going to be a plus 3 in the numerator. And then, now, you may say, well, can we factor that out? Actually, if you try to factor it out, you're going to find out that you actually can't. Because your only factors of 9 are 1, 9, 3, and 3. And when you FOIL it out, doesn't matter which factors you use, you're not going to get positive 3a, okay? But besides that, if this is, notice this factoring from up here, notice when I put this back in the denominator, notice that it actually is the same trinomial, which means we can go ahead and cancel them out. What else can we cancel out? Well, we can cancel out the a plus 3. Okay, and that leaves us with a minus 3 over a minus 3. So look at this. Everything that we've canceled out has become, all of this becomes 1, right? So a minus 3 divided by a minus 3, that's 1. 1 and 1. So you have 1 times 1 times 1 over 1 times 1 times 1. So our answer is 1. Okay. All right, let's go ahead and jump over here to number, let's see if we can find it, number 16. I'm just throwing papers all over the place over here. Reckless abandon. Okay, 16. All right, here we go. This is, okay, there we go. This is definitely probably the most complicated one that we're going to do. But let's do it. So we have x plus y, quantity to the negative second power, over y to the negative third power. Okay, and that's all being divided by x cubed, y to the negative second, times x plus y to the negative first, over x to the negative second power. All right. So what I'm going to do here is I'm going to come over to this side of the page, and I'm just going to rewrite everything. Remember, this is going to be x plus y to the negative second over y to the negative third times, remember, it's all being divided by, but we're actually going to multiply by the reciprocal of this right here. So that's going to be times x to the negative second over, okay, and that's going to be x to the third, y to the negative second, times x plus y to the negative first. Okay, everybody see what I did there? All right, so I'm gonna bring everything down here, and what we need to do is we need to deal with these negative exponents. So we're gonna just we're gonna take each one. I'm gonna start off with this fraction, and I'm gonna rewrite them with positive exponents. All right, so we're gonna do right here. So let's take this right here, right? Remember, with a negative exponent, you just simply bring this entire term to the opposite side of the fraction and change the exponent to positive. All right, so what that looks like is, let's go ahead and deal with the y to the negative third first. That's y to the negative third, so we're going to bring that y up here and make that to the positive third. Okay, then we're going to take this x plus y to the negative second, and we're going to bring that to the bottom, and that's going to be x plus y to the second power, which I'm going to go ahead and just break it up like that. This is the same thing as x plus y squared. I just kind of factored it out there. Or not factored it out, just kind of wrote it in expanded form. Okay, so now I'm going to do the same thing to this other fraction over here. All right, so we got this right here, right? We got this x to the negative second. That's going to come down to the bottom, and that's going to be Make sure I wrote that right. Yeah, that's right. So this x to the negative second is actually going to come down here. And notice that it's going to, eventually we're going to combine that with that x. So I'm going to go ahead and write that x cubed right there, because this x cubed right here doesn't go anywhere. It's positive, so it doesn't change locations. It stays there, right? Okay, but look at this y to the negative second though. That's going to come up here. So that's going to come up as y to the second. All right, so we've already dealt with this. X to the negative second came down here as x to the second. Y to the negative second came up here as y to the positive second. So we just have this right here, x plus y quantity to the negative first. Well, that's going to come up. That's going to go from the denominator up to the numerator as x plus y to the positive first, which I don't need to write. Okay, so let me zoom out here. Okay, so this is what we're working with now. Now notice we can go ahead and cancel out, because we're multiplying here. We can cancel out. We can cancel out here. Okay, is there anything else that we can cancel out? Not that I see. But we can go ahead and combine these. All right, so let's write everything that we have left. We have y cubed over x plus y times, over here we still have our y squared. And then we have, I'm going to combine these.